What becomes of reality when even time itself is swallowed whole? Across the ocean of stars, there are regions where light forgets how to return. These are not gaps in the sky, nor simple voids between galaxies. They are wounds in the fabric of existence, scars left by collapsed giants whose mass has folded in on itself until nothing recognizable remains. To approach one is to move towards silence, but a silence that is alive, watchful, consuming. Black holes. The very name carries dread, a gravity of its own. Not stars, not planets, not even shadows. They are places where space ceases to be a stage, and instead becomes a trap, where time is not an arrow, but a spiral, winding into oblivion. No sound escapes, no color lingers. And yet the universe is seeded with them, as if creation itself requires these abysses to balance its design. Imagine a star many times larger than our sun. For millions of years it burns, fusing hydrogen into heavier elements, its radiant pressure holding gravity at bay. But in its final breath, the fire weakens. Gravity, relentless and patient, wins the duel. The star implodes, its heart collapsing faster than thought. The core crushes into an impossibly small point. Around it, a boundary forms, the event horizon. It is not a surface, not a wall. It is a threshold. Once crossed, no signal, no matter, no whisper of information can escape. To the outside world, the star has vanished, leaving behind a silent abyss. And yet even silence can roar. For the space around a black hole is anything but empty. As matter spirals inward, it heats to temperatures beyond comprehension. Gas, dust, and fractured stars swirl into disks of incandescent fury, brighter than entire galaxies. To fall toward, such a place is to witness light itself tortured, bent into rings and arcs, distorted by gravity so intense it reshapes reality's lens. From afar, one does not see absence but spectacle, the paradox of a void shining brighter than creation itself. The event horizon stands as the most mysterious of frontiers. To the falling traveler, time seems to pass as usual, but to the distant watcher, that same traveler slows, forever frozen at the edge, never quite crossing. The image lingers, a ghost trapped at the border of forever. Time fractures, wearing two faces, swift within, motionless without. A single journey becomes two truths, irreconcilable, yet equally real. This duality hints at the strangeness beneath. Beyond the horizon lies the singularity, the central enigma, where equations shatter and laws collapse. Gravity crushes to infinity. Space curves without end. Time may not even exist in the form we know. Here, physics is silent, unable to describe the chaos within. What began as a star has become an unknowable knot of reality itself. Yet black holes are not passive destroyers. They shape galaxies, orchestrating the dance of stars. At their cores, supermassive black holes millions, even billions of times. The sun's mass anchor entire spirals and ellipticals. The Milky Way's heart beats around Sagittarius A, a supermassive black hole 4 million solar masses deep. Without it, the stars of our galaxy would wander unmoored. The abyss is not merely a tomb, but an architect. Still, the strangeness deepens. To orbit such a giant is to feel time slip differently. A clock ticking near the horizon drifts slower than its twin far away. Minutes stretch into hours, hours into centuries. To approach is to travel not only through space, but through time's distorted corridors. In the shadow of a black hole, time itself becomes pliable, subjective, mercilessly relative, and then the paradox grows sharper. Though nothing can escape the event horizon, Stephen Hawking revealed that black holes are not entirely silent. Quantum effects at the edge cause them to emit a faint radiation, Hawking radiation, as if the abyss slowly evaporates itself into the void. Given enough time, black holes may not endure forever. They could wither, fade, and vanish, leaving behind no trace of what they consumed. They are at once eternal and fleeting, destroyers and dissolvers of their own essence. But the greatest terror may be the loss of information. Every book, every memory, every particle of order that falls into a black hole seems, by classical reasoning, to be erased. Yet in physics, information cannot simply vanish. The cosmos keeps records, hidden in its particles and waves. If a black hole erases information, the universe breaks its own rules. And so, the abyss may hold secrets far stranger than destruction. It may encode reality in ways we have yet to imagine, storing the story of what it swallows in patterns written upon the horizon itself. The mind strains to imagine what lies inside. Could black holes be tunnels, wormholes to distant realms, bridges between universes? Might each collapse give birth to a new cosmos, budding off from ours like seeds of infinity? Or are they simply prisons, traps where matter and memory are forever sealed? The questions multiply like stars, yet answers remain distant, veiled by the horizon's silence, and so humanity circles them from afar, gazing at distorted starlight, detecting X-ray flares, capturing their shadows with telescopes spanning the Earth. We observe not the abyss itself, but its effect. A fingerprint pressed into space-time, a dark silhouette against glowing rings. What we know is only the outline of mystery, never its core. Black holes are not monsters lurking in the void, though they terrify. They are essential, woven into the design of galaxies, guiding the evolution of structure across billions of years. Yet they remind us of our fragility, of how easily the familiar can collapse into the incomprehensible. They are mirrors, reflecting back our hunger to know, our fear of unknowing, our search for meaning in the infinite dark. Even now, as telescopes sharpen their gaze and theories stretch toward new horizons, the truth of black holes remains out of reach. They stand at the frontier where knowledge falters, where science begins to sound like poetry, and where the cosmos reminds us that not all mysteries yield themselves to understanding. The abyss waits, patient and impenetrable, whispering questions through its silence. To step closer is to invite wonder and terror in equal measure. And yet humanity has always answered such whispers. The story of discovery begins, not with fear, but with a spark in the dark. The story of black holes does not begin with their naming, nor with photographs of their shadows cast across galaxies. It begins with wonder and with suspicion, a recognition that the night sky might conceal more than it reveals. In 1783, John Michell, an English clergyman and scientist, considered a thought both radical and haunting. He reasoned, if a star grew massive enough, its gravity might be so strong that even light, the swiftest messenger of the cosmos, could not escape. He called them dark stars. At the time, light was thought to consist of tiny particles, obedient to gravity like stones. Michel's insight, centuries ahead of its age, was filed away in obscurity. The universe had whispered its first hint, but humanity was not yet ready to listen. In France, Pierre-Simon Laplace echoed the same speculation, pondering invisible giants in his Exposition du Système du Monde. Yet in an era before relativity, before an understanding of light as both wave and particle, the idea seemed a curiosity, more philosophy than science. And so the dark stars drifted into the margins of history, a candle lit, but soon forgotten. Then, more than a century later, war reshaped the world and the universe of thought. Amid the mud and thunder of the First World War, a young German physicist, Karl Schwarzschild, studied Einstein's newly published general theory of relativity. From the chaos of the trenches, he found clarity in equations. His solution to Einstein's field equations described something extraordinary, a point mass so dense that space and time curved infinitely around it. It was the first mathematical fingerprint of a black hole, though the term did not yet exist. Schwarzschild himself would not live to see the storm his solution unleashed. Disease claimed him months later. But his equations endured, silent blueprints of cosmic abysses. At the time, even Einstein himself hesitated. He could not imagine nature permitting such monstrosities. For him, the equations revealed boundaries of theory, not realities in the night sky. The abyss remained theoretical, waiting for evidence to give it voice. As decades passed, the pieces assembled slowly, almost reluctantly. In the 1930s, Subrahmanyan Chandrasekhar, traveling by ship to England, scribbled calculations that revealed the fate of massive stars. If a star exceeded a certain mass, it could not stabilize as a white dwarf. Instead, it must collapse into something denser, stranger. His conclusion was met with fierce opposition, most famously from Arthur Eddington, who dismissed it with almost paternal scorn. The idea that stars could collapse without limit seemed grotesque. Yet Chandrasekhar's mathematics was relentless, a candle burning against disbelief. The war returned, this time global in scale, halting the march of discovery. But in the aftermath, with the rise of radio astronomy and X-ray observatories, the universe began to reveal its hidden engines. Signals arrived not in visible light but in radiation, flickers from unseen sources. In the 1960s, astronomers detected Cygnus X1, a powerful X-ray emitter. Around it, a companion star wobbled, tugged by an invisible partner. No star was present, no shining companion, only a dark mass, drawing matter into its unseen maw, igniting X-rays as gas spiraled toward the horizon. For the first time, a candidate black hole had stepped from theory into observation.
The void had left its signature on the sky, and so the term black hole was born. In 1967, physicist John Archibald Wheeler, during a lecture, reached for a phrase to describe this phenomenon. Black hole, stark, simple, and resonant,
captured both the science and the dread. The cosmos had a new vocabulary, one that would grip the imagination of scientists and storytellers alike. Yet discovery is never a straight path. Some saw these X-ray sources as neutron stars, dense remnants that stopped just short of the abyss. But the masses calculated for Cygnus X1 exceeded those limits. Whatever lurked there was heavier than physics allowed for neutron stars. The verdict leaned toward the impossible. The invisible dark wells first envisioned by Michel had, at last, taken shape in the modern sky. But it was not only stellar corpses that emerged from theory. Astronomers noticed another puzzle. Galaxies themselves seemed bound to hidden anchors. Stars swirled at speeds that demanded immense central masses, yet no cluster of stars was visible at their cores. Could supermassive black holes, millions to billions of times heavier than the Sun, be hiding there? The idea was staggering, almost mythic. Not just dead stars, but cosmic behemoths sculpting entire galaxies. Gradually, evidence mounted. Quasars, discovered in the 1960s, shone with energies dwarfing whole galaxies, powered by matter falling into unseen engines. They were not stars, but the blazing throats of supermassive black holes, feeding in the distant universe. The whispers had become a chorus. The abyss was real. What began as a speculative thought in an English garden, refined in the mud of war, doubted by giants, and confirmed by light itself, had become undeniable. Humanity had uncovered a new kind of object, not an object at all, but a boundary where existence folds in upon itself. The spark of discovery was never a single flame, but many, scattered across centuries. Michel's invisible star, Schwarzschild's equations, Chandrasekhar's limit, Cygnus X1's invisible pull, Wheeler's naming. Each was a flicker, fragile and contested, but together they lit the path toward understanding. The abyss was no longer legend. It was measurable, detectable, anchored in mathematics and observation. And yet, with each confirmation, the mystery only deepened. Last lines, what was once speculation, had become undeniable reality. But with reality came questions even stranger. What truly happens at the edge of no return? The next chapter unfolds where observation meets paradox, and the mystery of black holes begins to unravel into even darker enigmas. At first glance, the black hole seems simple enough. A region where gravity is so strong that nothing, not even light, can escape. But simplicity is deceptive. The closer one draws to its frontier, the more the familiar rules begin to warp, until physics itself bends and breaks. The event horizon stands as the first boundary, an invisible curtain. To cross it is to accept a one-way fate. For an observer watching from afar, anything falling in appears to slow, approaching the horizon asymptotically, never quite vanishing. Time stretches like glass, freezing the traveler on the brink. Yet, for the traveler themselves, the passage is unremarkable, smooth, even ordinary, until the inevitable pull toward the center. Two perspectives, both true, yet mutually irreconcilable. Already, reality fractures into paradox. Beyond the horizon lies the singularity, the point where mathematics collapses. Here, density soars toward infinity, and space-time curves beyond comprehension. It is a place not of matter, but of broken law. General relativity, the great triumph of Einstein, ceases to function. Physics, the careful language with which humanity describes the cosmos, falls silent. What replaces it? Perhaps a new theory, one uniting quantum mechanics with gravity. But for now, the singularity is a blank page, a void even in human thought. Still, science presses forward. Theorists imagine the singularity not merely as an end, but as a gateway. Some propose it could birth new universes, each black hole in our cosmos serving as a seed. Others wonder if it hides wormholes, tunnels that link distant regions of space and time. To journey inward might be to emerge elsewhere, somewhere else. These are not certainties, but speculations perched on the edge of imagination. And yet, in the presence of a singularity, imagination feels almost mandatory, for the universe offers no clear alternative. Even outside the event horizon, mysteries multiply. The phenomenon of spaghettification, matter stretched and thinned by tidal forces, paints a picture of destruction both terrifying and awe-inspiring. A star wandering too close is torn apart, its gas forming bright, spiraling streams, briefly igniting before vanishing into shadow. Black holes are not static. They feed, they flare, they shape. Their hunger leaves fingerprints written in light. But perhaps the strangest revelation of all came from Stephen Hawking in the 1970s. Until then, black holes were thought to be eternal, devouring everything but giving nothing back. Hawking, blending relativity with quantum field theory, showed that black holes are not perfectly black. At their horizons, quantum fluctuations allow particles to appear and escape, stealing away the black hole's mass in the process. Slowly, invisibly, they evaporate. A giant millions of solar masses would take longer than the age of the universe to vanish. But the principle was staggering. Black holes could die. They were not eternal prisons after all, but objects with lifespans. This revelation opened a wound in physics, the information paradox. If a black hole evaporates entirely, what happens to the information carried by everything it has consumed? The laws of quantum mechanics declare that information can never be destroyed. Yet the black hole seems to erase it utterly. The universe does not tolerate such contradictions lightly. Either the laws of physics break at the horizon, or the black hole somehow encodes the information on its surface, as though the abyss itself remembers. This idea blossomed into the holographic principle, the notion that the universe's information might be stored not in volume, but on surfaces, like a vast cosmic hologram. If true, reality itself may be far stranger than imagined, a projection written on the boundaries of existence. And all of this insight emerged not from distant galaxies, but from pondering the silence of black holes. Still, no theory rests unchallenged. Some physicists propose firewalls at the event horizon, infernos of energy that would incinerate anything crossing. Others insist the horizon is smooth, seamless, obeying relativity's elegance. The debate continues, unresolved, each possibility redefining our conception of reality. In this sense, black holes do more than consume stars. They consume certainty. Every theory drawn toward them is tested, stretched, sometimes destroyed. Then there are the whispers of wormholes. Einstein and Nathan Rosen once imagined bridges formed by extreme curvatures of spacetime, tunnels linking distant points. Could a black hole be one mouth of such a bridge, its twin perhaps opening elsewhere in the universe? Some models suggest yes, though they remain fragile, unstable, collapsing faster than anything could travel through. Yet the dream persists, that within the heart of destruction lies a path to elsewhere. Meanwhile, observations sharpen. The Event Horizon Telescope revealed the first image of a black hole's silhouette in 2019, a glowing ring encircling darkness at the core of galaxy M87. It was not science fiction, not theory, but a photograph, humanity gazing directly at the mouth of the abyss. What was once abstraction now had a face. And yet, that face raised even more questions. Could these objects, once feared as cosmic monsters, be fundamental to creation itself? Supermassive black holes regulate galaxies, their outbursts shaping the birth of stars. Without them, galaxies might collapse into chaos or drift into disorder. They are not outsiders to cosmic evolution. They are architects. They destroy, but also create. Thus, the paradox deepens. Black holes are at once devourers and sculptors, eternal and impermanent, simple in definition but infinite in implication. Each new theory births another. Each discovery expands the labyrinth rather than resolves it. The closer we peer, the further certainty recedes, as if the black hole itself resists being fully known, a cosmic trickster guarding the deepest secrets of reality. Last lines. The abyss reveals not answers, but deeper riddles. It is where physics falters and imagination begins. Yet beyond speculation lies reflection. For what black holes conceal is not only the fate of matter, but perhaps the meaning of our place in the cosmos itself. At the edge of understanding, black holes no longer feel like objects. They feel like questions given form, mysteries cast into gravity's shape. To gaze at them is to glimpse the unfinished sentences of the universe, punctuation marks where the known stops and the unknown begins. We have followed them from speculation to theory, from mathematics to image. Yet even as science presses its instruments closer, what emerges is not clarity, but reflection. Black holes are mirrors. They force us to confront not only the cosmos, but ourselves, our fear of oblivion, our hunger for meaning, our fragile confidence in reason's reach. For they are not simply destroyers, they are sculptors. At the heart of galaxies, their presence shapes the birth and death of stars. Outbursts from feeding black holes regulate the clouds of gas that form suns. Without these central giants, galaxies might collapse inward or scatter apart. The abyss gives structure, turning chaos into architecture. In this sense, every starry night owes its order to the dark giants at galactic cores, but their influence reaches further still. Consider time itself. Near a black hole, time stretches, slows, fractures into relativity's strange dance. To orbit, such an object is to drift into a slower rhythm than the universe beyond. The abyss does not simply bend space, it bends the experience of existence. In their shadows, time is not absolute, but malleable, a reminder that what feels universal may be only local, fragile, contingent, and then comes memory. If information is never lost, as quantum theory insists, then black holes are keepers of every particle, every pattern, every life that has ever fallen into them. Perhaps their horizons are cosmic archives, storing the universe's history in a language too deep for us to read. They may be libraries written in the geometry of space-time, every photon and atom inscribed in subtle distortions. If so, black holes are not erasers, but scribes, preserving reality in forms beyond comprehension. This possibility transforms their image. No longer tombs, but vaults. No longer endings, but transformations. In the black hole, matter becomes information. Information becomes geometry, and geometry becomes memory. The abyss remembers. Yet even this is uncertain. The paradox of information remains unresolved, one of the great unsolved riddles of physics. If black holes evaporate, what happens to their archives? Does the universe truly keep every record, or is forgetting woven into its design? Perhaps black holes hold an answer to the question of mortality itself, whether anything is truly lost or only changed. In their silence, they also whisper of creation. Some cosmologists imagine that every black hole might seed a new universe, budding off from its singularity into a separate reality. Our own cosmos, with its expanding galaxies and arrow of time, may have begun inside the heart of some parent universe's collapse. If so, black holes are not graves but wombs, gestating new realities in their depths. Endings and beginnings merge, indistinguishable. The thought is unsettling and beautiful. It turns destruction into genesis, annihilation into origin. The dark becomes fertile. And in contemplating this, we are forced to see our own lives differently. Every ending may hold the seed of a beginning we cannot yet perceive. Still, black holes remain terrifying. To fall into one is to surrender the possibility of return. Spaghettification, collapse, and silence await any traveler who crosses the horizon. But terror and wonder are twins, born of the same recognition that the universe is greater than us, stranger than us, and indifferent to our limits. Black holes remind us of this truth with overwhelming clarity. And yet, fear has always been the companion of discovery. Humanity has never turned away from the abyss for long. From Michel's speculation to Hawking's paradoxes, from the first X-ray binaries to the Event Horizon Telescope's image, the pattern is constant. Step closer, confront the void, and emerge with questions sharper than before. The abyss resists, but in resisting, it draws us forward. Perhaps this is their ultimate meaning. Black holes are boundaries in the fabric of the cosmos, but they are also boundaries in the fabric of the human mind. They mark the point where explanation dissolves into mystery. To encounter them is to feel the limit of reason, and to keep reaching beyond that limit. The curtain of the universe draws near, but behind it, we sense a stage far vaster than imagined. Black holes are the cracks in the curtain, allowing a glimpse of what lies beyond, even if only for a moment. They humble us, reminding us that our maps of reality are incomplete, our equations provisional, our certainties fragile. And in that humility lies wonder, the same wonder that has driven every discovery, every act of science, every step into the dark. So the question remains, what are black holes truly? Are they tombs, vaults, wombs, or mirrors? Are they singularities of gravity or singularities of meaning? Perhaps they are all of these, or perhaps they are something we have not yet language for, and beyond even that lies the most haunting possibility of all. What if the universe itself is a black hole? Its galaxies and stars swirling within an event horizon so vast that we cannot see its boundary. Expansion itself could be the unfolding of space inside a cosmic horizon, our entire reality suspended inside a larger shadow. If this is true, then every gaze at the night sky is a gaze from within the abyss. We are not outside it, but already inside, inhabitants of a cosmic interior we mistake for the whole. This thought cannot be proven nor dismissed. It hovers at the edge of knowledge, unsettling and irresistible. The universe remembers, in the light of stars, in the silence of horizons, in the questions that refuse to fade. To wonder about black holes is to wonder about ourselves, our fragility, our courage, our longing to know. And as the curtain closes, one question remains. What if the shadow we fear is not outside us, but the very cosmos we call home?